What I want to talk about today is the use of faults and the concept of using faults within GVERSE geomodeling, including some tips and tricks, etc. Okay, some of the things I want to cover here are the basic fault concepts in geomodeling and how they're created, how they're edited, etc., including a tool that some folks that use GVERSE geomodeling may not even be aware of, which is the ability to interactively fault gap, or gap faults, I should say, within cross sections, within stratigraphic cross sections in geomodeling. And then I want to, from there, I want to show how fault polygons that are created by the model on the fly can be used in IsoMap for gridding and contouring. Okay. Then I'm going to go ahead and switch to creating and editing faults in both cross-section and map view, and talk about, subsequently switch to a different project and talk about a number of options for sourcing your faults, including how you can source a fault from a seismic interpretation, say GVERSE Geophysics or Size Vision, and also how you can use an IsoMap layer to source faults. For example, if you can get a grid from another program where you have created faults, talk about how we can actually use that to source faults. Okay. So without further ado, let me launch into the demonstration. I'll go ahead and end the slideshow. So here I'm in GVERSE geomodeling. I've already opened the tool. I've created an interpretation, and this is actually the resurrection, at least the northwestern part of this is a resurrection of an old demonstration data set that we used back in the original smart section in the South Pelto offshore area of Louisiana state waters. Okay, I'm going to start with that, and I'm going to go ahead and zoom in to that particular area here in the northwest. Okay, so what we have here is an area where I've created a cross section. I'll show it to you in a second, and you'll notice that I've got a surface that is showing up here. It's called the stone surface, and there is a fault polygon showing up. Okay, and that's what we're looking at here, and then an active cross section from north to south. So let me go ahead and pop that cross section up. So that's our cross section there. And as you may notice, we have a fault running through here from lower right to upper left center. And I'm going to hit the F4 key and show you something here. This is the fault and I'll go ahead and hit Control Spacebar. This is the fault, and Control Spacebar, by the way, datums this cross-section structurally. So this fault has been picked on 4 wells in this cross-section already. And you may notice that the area where it was picked, or these, I should say the stratigraphic interval where it was picked in a number of these wells, let me zoom in the the lower right portion of the cross section, shows an abrupt thinning of an abrupt stratigraphic thinning. Essentially what you have here is some faulted out section. Let me pop back. I'm now going to go ahead and datum the cross section. I'm going to click on this upper green horizon here called the green 2-1, hit the space bar to hit the datum on that stratigraphically, and I'm going to hit the F4 key, which is equivalent to a right click, draw modes, right click gapping fault option, F4. So essentially what that's going to do, that F4 is going to show you that this fault has already been gapped by the user. So essentially what's happened here, let me go to this well here on the left side of the cross section, left center of the cross section. Essentially what's happened here is an interactive gapping based on the stratigraphy. So I just closed this gap on this well. Okay, there we go. And this is the way that when you first pick a fault, I'm going to show you this in another area to the south of this here in a second, where I actually do the interactive gapping. Essentially this is what happened here, right? The user said, hey, I need to gap this fault in order to reconstruct the stratigraphy. okay, interactively. And when you do that, whoops, let me go up here. When you do that, there is a vertical separation value that's automatically generated by geomodeling. Okay, so you can, of course, directly enter these vertical separation values. However, when you do this interactive fault gapping, the vertical separation values are taken care of for you. Okay, so that's how that fault was picked. That's how those vertical separations were determined, by interactively correlating, if you will, in stratigraphic mode and gapping the cross section in order to restore the section, gapping the faults in order to restore the section. Okay, now let's go back to the map on this guy. Oh, before I do that, I wanted to show you what this cross section looks like in a different mode. So let me pop up another version of that cross section. Here it comes. There we go. Same cross section, showing the wells in, this is a projected cross section now, I'm sorry, a proportionally spaced cross section, showing you the wells in deviated well mode. Obviously, the previous cross section was simply true vertical depth, where I did on my where the correlation was done, I should say. And here you can see a much more realistic depiction of the fault plane. By the way, the dipsy doodling of the fault in the central part of this cross section is due to the fact that this well has a very odd directional configuration here, even though it's virtually straight. So don't worry about that. That's not an error. It's just an artifact of the directional survey of the well. And then you can notice that with fault offset applied up here, that's our fault offset tool, of course, within geomodeling. With fault offset applied, let me zoom into the lower right portion of the cross section. There you can see the offset on, let's say, this particular blue surface, which is called the stone surface. Okay, so with the gapping, it's offset these surfaces automatically, and that generates a fault polygon in map view. So let me click up here to go to map view. So what I've shown you here is this stone surface with the fault polygon, okay, right here. And the fault polygon is turned on. Let me go to the actual fault. The fault polygon is turned on by going to the specific fault. In this case, it's called the SP fault, the South Pelto fault. Under the faults, there should be a plus sign when you turn on something like fault offset with unconformities. If you turned on unconformity trimming, you'd have a plus sign next to your unconformities where they are intersecting surfaces. In this case, the software, the geomodeling software, recognizes all the surfaces that SP fault intersects. Okay, and I've simply turned on the stone intersection with fault offset on, and I get a polygon. If I wanted to move up section slightly to the brown 3 and the brown 2, you can see the fault polygons are migrating along the fault plane. Okay, so you can turn on multiple fault polygons. All right, so that's what's going on here. Now, subsequently, what I did was I took the stone surface. Again, here I am in my geomodeling data tree, if you will, geosurface modeling data tree under correlations unconformities. I clicked on the stone, I right-clicked, and I said create IsoMap layer. And that gives me a pared down version of the IsoMap layer create dialog. I'm not going to go through the entire process, but I'll pop it up real quick and show you. And it gives you, and you name your layer here, and it gives you the option to include intersections and fault polygons, which I did. Okay, so now let me go ahead and go to Geo Atlas, where I've already made a simple stone surface subsea structure map. Okay, this is an IsoMap layer in Geo Atlas. This stone from GVERSE Geomodeling, up here you can see my second layer, which has got the eyeball closed. That's the one that I pushed over from GVERSE Geomodeling. Okay, now I'm going to go ahead and open the eyeball on that guy, and I'm going to close the eyeball on my simple stone subsea. This is the layer that got pushed over. You can see the crosses, which are the data points that came over from GVERSE Geomodeling, And here's that fault polygon sitting here right in the middle. Let me go ahead and click on it. I think I cheated. Let me go to my entity filter. No, I didn't cheat. I actually, normally what you would probably want to do is turn off all the other entities that are available on this layer and just have the fault polygon entity available. That way you're not going to have any problem grabbing it. You can do a simple swipe with your selection tool and get your fault polygon or fault polygons if there's multiple polygons. And one of the interesting things about these fault polygons that get pushed from geomodeling, let me click on the node, the node display edit here. You can see all of these different nodes, and then let's see, if I right click and I go to data attributes, you can see that every one of these nodes that is pushed over from geomodeling has a subsea elevation. So this is a very smart fault polygon. So what that means is, let me get out of my node edit mode here. What this means is that I can copy this fault polygon to the clipboard. Now I'm going to turn on my regular stone subsea here and go back to and turn off the eyeball on the stone from GVERSE Geomodeling there. And you'll notice, of course, that this stone subsea surface in IsoMap doesn't have any fault interpretation on it. But what I'm going to do is I'm going to paste the fault polygon that was generated in GVERSE Geomodeling and pushed over to IsoMap. I'm going to paste that guy onto this layer, and now I'm going to update the active layer, the only layer on the map, right? And I'm going to go ahead and interpret faults. I need to regrid this guy when I interpret the faults, and I'll go ahead and got a boundary polygon on here. That's good. It won't go crazy away from data. I'll go ahead and regrid this guy with my fault polygon interpreted. Let's see what we get here. There we go. So there is our new IsoMap layer with that fault polygon interpreted. Let me cruise across with my panning tool, and you can see areas where it actually has, it's showing you the offset there. Not a tremendous amount of offset in some parts of this area, obviously, but in some places clearly there is, based on the vertical set. Whoops, didn't want to go all the way back out there. Hang on, guys. There we go. And some years ago, when geomodeling was still fairly new piece of software, we had a geologist out in California who used this particular workflow constantly. Had a layer, kind of a master IsoMap layer, if you will, and would use the modeling tool to add, edit faults, etc., generate the polygons, push the layer up to IsoMap just like I did here, and then grab the new, let's say, new fault polygon in a new area, paste it onto the master IsoMap layer like I did here, and then regrid the thing so that the new fault polygon would be incorporated into the interpretation on that layer. Okay, so that's an example of an existing fault that was picked in the South Pelto area, and how you can use the fault polygon that was generated from a particular fault at a particular surface in IsoMap as well. So let me minimize IsoMap. Now I'm going to go ahead and pop out to full extents and go down to this area to the south. Let me go ahead and zoom in down here. As you can see, I've got a little cross section created in here. So I'm going to go ahead and let me make sure I can open that guy. He is naturally, let's see, hang on. Go up to my cross section, be the second demo section. Naturally not. There we go. XS1. Let me open him. There we go. Come on. So this is a cross section through all of those wells. And what I wanted to point out was how you can kind of recognize an area where you might have missing section and generate a new fault, and then go ahead and gap it. And then I want to show you how to edit it in map view. Okay. And by the way, the editing in map view is interesting, and it can also be applied to surfaces, so it's not just faults that you can do that with. So let me zoom into this part of the cross section, and assuming these correlations are correct, I actually don't think all of these are bogus correlations, to be honest with you. Some of them are very real. You can see the pinching, if you will, in a couple of places, the hourglassing of the correlations, suggesting maybe you've got faulted out section in this part of the world offshore Louisiana. So what I'm going to do is click on the asterisk up here in the cross-section view in the upper left, which allows me to create a new surface, a new fault, unconformity, etc. I'm going to create a new fault, and I'll simply call it F1. I better call it, you know what, I'm going to call it F3 in case I called that fault F1 previously. I gotta be careful with that, right? And I'm going to color this thing. Let me go to the custom, make it a little easier. I'm going to color this fault red. Okay, there we go. So created an F1 fault, and over here under surfaces, you see there's my, I'm sorry, my F3 fault. There's my new F3 fault. It's been added to the fault list down here, and it's also, so it's been modeled, right? You don't have to go to GeoSurface model properties and model the darn thing. And it's checked, ready to go, okay, and it's active. So now all I need to do is go up to my fault picker, which is right here. There's my selection tool, there's my surface picker, and there's my fault picker. Click on my fault picker, make sure my F3 is still active, and it is. And I'll just pick it in a couple of places here and gap it. So I'm going to go ahead and click here. I'll just say it's in this interval in here somewhere. And then right up in here, you can see this abrupt thinning. I'll click there as well. And then I will go back. I'll hit the tab key to go back to my arrow tool. Anytime you're in cross-section mode in geomodeling and you're in a particular tool, you can hit the tab key to go back to the arrow. And I'll hit F4 to go into gap mode, and I'll left click on this guy. Whoops. Let me zoom in a little bit here. Again, just as a reminder, the F4 hotkey is gapping fault, and you can see it's actually on. So now I grab my fault. I'll grab this one up here, and in order to gap it, you drag down. So I'll go ahead and gap that fault to restore the stratigraphic thickness, if you will, and I can gap this guy down here maybe slightly differently. Let me grab him. I can adjust the gap until I get what I consider to be the correct stratigraphy, and in fact, look how much thicker it is over to the left. Let me drop him down. So it may be something like that where this whole unit is thickening. Okay, so there's my fault gap. So I've got vertical separation calculated, and I've got a, and obviously I've got the fault only picked in a couple of places. Oh, in fact, it actually looks like there might be something going on over here. Let me go back to my fault picker, make sure F3 is highlighted, and I'll go ahead and pick the fault here as well. And then hit the, and it gapped base. It's essentially extrapolated the gap, and that looks reasonable. I'll go back and hit the tab key and adjust the gap slightly. All right. And then, and let me grab this well and move it interactively, of course, in geomodeling. And I'll go ahead and say, you know what, everything looks normal over here. I'll go ahead and add a fault point, make sure F3 is highlighted down here, between wells. So I'll send this fault, whoops, I'm in straight line mode. Hang on, guys, let me go to F8. Now I'm in true space mode, and I'll go ahead and click, and I'll have that fault kind of shooting up to the north, or up between those two wells. There it is. Now what I'm going to do is go back to map view. All right, and I'm going to turn on that fault. There he is, F3. I'm going to click F3 on, and there is the F3 fault plane based on my picks in, what, 3 wells and also an interwell pick. All right. I want to show you how you can edit this fault within map view, and again, you can do the same thing with surfaces. So let me zoom in a little bit. Okay. Let me make sure that F3 is my quote-unquote active surface, so I'll right-click over here in the fault list and say activate surface. And now what I can do is I can click on this arrow with a plus sign right there, which is sort of my interwell picking mode. And if I interpret this fault to extend farther east and wrap around like this, I can click anywhere within the modeled fault plane, anywhere I have correlations, I'm sorry, anywhere I have contours. It'll create a new interwell point at that subsea elevation, which I can then drag beyond the confines of the current model, and it will in fact extend that model. Okay, so if I think that the fault probably extends a little farther north over here at that elevation, I can add a point, and I can continue to edit that fault, adding interwell points. Okay, and let me go ahead and add one down here and extend it farther to the west. So you can configure the fault, go back to the arrow tool, whoops, go back to the arrow tool. You can configure this fault plane in map view any way you like. Now, in addition, you can come in and create what I call an arbitrary cross section, as if you were working with 3D seismic, and you can add points to the fault plane that way as well. Okay, so what I'm going to do here is I'm going to go up to cross section, define well to well, and I don't actually have to pick any wells. I can just slice through this geomodel anywhere I want, and I'll click, double click to create my 2-point cross section. Let me grab the right hand XY point and drag it out. And so there is my fault. If I had a couple of monitors here, what I would do is I'd probably move this around a little bit. Let me actually see if I can go to pseudo 2-monitor mode here for you real quick. Let me resize this map window. There we go. So I could actually, let me drag you over here. So I could actually move this around, and you see I can get the fault to show up in different areas and show the fault configuration. And if I decided that I wanted to go ahead and, let me maximize that guy. If I decided I wanted to go ahead and reconfigure the fault in this area, I could do the same thing. Grab the fault picker, go to my surfaces tab in the lower left, make sure F3 was highlighted, and say, you know, I think this guy probably shoots up here and maybe shoots down here. And I can go ahead and pick a couple of hard points and reconfigure the fault in cross-section view as well. Okay, so let me go back to map view here. There we go. And I added, you can see these interwell points I added there and there. And just like in the first example I showed you, I could then take this fault plane, and create an IsoMap layer of it, and those data points would come over. So I could use that fault plane in IsoMap as well, or I could offset it and use the fault polygon from this guy. So that's how you can actually create a brand new fault, pick it, gap it, and then use it in IsoMap as well. And by the way, if you have information already in Wellbase about vertical separation, when you have the fault picked in wells, of course, you can use that. One of the nice things about this trick using cross sections and then the map is that you do not need to actually see the fault within wells. So in a lot of cases, people have identified faults from seismic, and or maybe from field work. I think I have one fellow who has been doing some field work in California and recognizes the fault and hasn't seen it in any wells, but knows it's there, so actually picked it in between wells using a cross-section workflow similar to what I just showed you. Okay, so hopefully that makes some sense. Let me go ahead and resize these guys. You see the fault readjusted itself in here. All right, I want to switch gears a little bit and go to another project and show you how you can source faults from different, essentially from different sources. Okay, actually, let me close these cross sections. Close this guy. I'll save him. Bear with me while I close these guys up. And I'm going to pop into our Sacramento Basin Geology Tutorial Training project. Go to an AOI called 3D Survey Area. I'll go ahead and activate that. There we go. Sure, I'll save changes to my last interpretation. I'll go into our Smart Section tutorial. Probably squawking at me about my map, so I'll go ahead and save the changes to the map. It's thinking. There we go. So now we're completely out of Louisiana offshore, no little red check marks. And I'm into the 3D survey area here. Okay. And what I'm going to do is go back to my geomodeling map view. There we go. All right. So this is our small 3D survey area that we use for geomodeling training. And you can see I've got a number of wells in here. I've got a cross section from north to south. And I'm actually showing a couple of, there we go. I'm actually showing, well, I'm showing one fault, the Beehive Fault. That's a fault plane down here. And I'm showing this funny looking thing in here as well. So let's talk first about the Beehive Fault. You may notice that the symbol next to the Beehive Fault is not well base or a hybrid of well base and IsoMap. It is SizeVision / GVERSE Geophysics. So how did that happen? Well, let me go up to GeoSurface Model Properties. This is 2019.2, and I've got a ribbon toolbar now. And I've added a couple of my oft-used tools like GeoSurface Model Properties to my custom quick access toolbar up here, so we don't have to click around, right? And go ahead and go to GeoSurface Model Properties, show you how this Beehive Fault's configured. All right, so here we have surfaces, here we have faults. There's the Beehive Fault. I'll click on him. And you'll notice over here on the lower right, the fault source is actually GVERSE Geophysics. So I have a Sacramento Basin 3 seismic interpretation saved in this project, and a Beehive Fault, and that is what I'm using to source the Beehive Fault in geomodeling. Okay, so let me open my cross section and show you the Beehive. Go up here, it's demo 1. I'll right click and say open. So here comes my cross section. Okay, there it is. And I have actually simplified this greatly. I've got mostly vector logs in here. I've got a single raster in my cross section. Simple cross section. Let me zoom in on the right side where the action is taking place. So here's the Beehive Fault. And here is, let me go to surfaces over here. That is what we call the K4B Surface. And as you notice, the K4B Surface is also sourced from geophysics, from a seismic interpretation. This fault will also affect regular surfaces. So if you have a correlated surface in well base only that kinks through here, and I don't think these guys actually do kink through here, you will see the offset once you turn the fault offset tool on. And in this case with the K4B, just like we saw before, let me go to map view and let me turn the K4B surface on. So there's the K4B surface, and you will see the fault in through here. This is a much more complex surface than you're probably used to. I'm sorry, it's actually down here to the south, right in there. Much more complex surface because, again, it is sourced from seismic. Okay, so the bottom line here is if you have a seismic interpretation in GVERSE Geophysics, SizeVision, etc., and you've got faults and or surfaces, right, you can source them. Okay, and let me zoom into this Beehive Fault down here. And you'll notice a fault polygon, and in fact recall that if you have a little plus sign next to a fault in here, that means that the software is recognizing one or more correlation or unconformity intersections, and it's got 11 of them in here. Got a bunch of pics, and I'm actually showing you the K4, let me turn it off, there it is. I'm actually showing you that K4B fault polygon. Alright, so in a similar manner I could push this up to IsoMap and use it in an IsoMap layer if I wanted. Okay, now So there's an option for you in terms of sourcing your faults. Let me pop back to the full map. Now, what the heck is going on up here with all these red dots? All right, let me show you what's happening. Up here under Geo Atlas layers, and recall in GVERSE Geomodeling, you can add any layer to the map that you can add to Geo Atlas. What we're looking at here is a layer called F1 new. All right, now, yeah, I knew I'd picked an F1 fault. It just was in a different project. So the F1 new fault, I'm gonna conjure up a little story here that actually occurred. I'll tell you the kind of the origin of one of these things. So we had a user who had a number of faults picked in a different software package and wanted to use those in GVERSE Geomodeling. And so what we did was we exported those fault planes, the grids actually of those fault planes, as ZMAP plus grid files, right? Which can then be imported in Geo Atlas and an IsoMap layer created. So let me see. If you go and let me actually show you that process real quick here. So if you create, I'm going to create a new layer, a new IsoMap layer here. From XYZ data, and my data source, and I'll just call this test up here. My data source would be an existing, it would actually be the ZMAP plus XYZ. All right, and you can bring it in, you can bring in the import file, and you can actually, so you could create a layer, and then once you create that, you can bring in an existing layer, right? Got a little ahead of myself there. You can bring in an existing layer, and let me go ahead and I'll just grab the F1 new layer. It's just an IsoMap layer. All right, and I can use the grid mesh. So in the case of the ZMAP Plus, it was simply a grid from this other, it was a grid of the fault plane from this other software package. You bring in the IsoMap surface grid mesh, all right, and you convert the grid nodes to XYZ. Okay. Now, so they actually can become data points. All right, those grid nodes can become data points on your IsoMap layer. That's the key. Let me show you why. And that's what I'm showing you here. This guy right here, that layer, that F1 new, those are all data points. In fact, just to push the point, let me create a new map and bring that guy in real quick here. F1 new, okay. There it is. All I'm showing are the data points. Let me zoom in. I made them little circles instead of crosses. And of course, I could go to layer display attributes, come back over here, there you are, data point, automatic label, and turn them on. Let me do a quick preview and see if they're big enough here. A little too big, so let me go to like 15. Let's see if that works. Preview. There they are. Okay. There's the data points. You can see the values coming over. All right, so we have a very high density of data coming in from that other data source. So that's what we're showing over here. All right. Now, whoops. You'll notice, where are we here? There we go. You'll notice under faults, let me close up the Beehive fault. We have this fault 1, this F1 fault, which I can turn on, and there's the fault plane. What's that coming from? Well, let me go back to GeoSurface Model Properties, go to Faults, go to the Fault 1 fault. Notice that I'm sourcing this fault not like the Beehive from geophysics, not strictly from Wellbase, but from Wellbase and IsoMap data points. All right. And the AOI the layer is in that has the data points is the 3D survey area, and the layer is F1 new. All right. So I've kind of got a dual source for this layer, and I'll tell you why I'm doing well base in a second, because there are no well picks in here, but I'll tell you why. So there we go. There's our source for the fault 1, for the F1 fault, or fault 1. Okay, let me cancel that. So there's the data source. I'm going to hide that by going up here and turning off that layer, right? I was just simply showing that layer. Now I'm going to go back and show the fault plane. So there's my fault 1 fault plane, okay? And you may notice, and again, that's primarily sourced from those data points that may have come in from a completely different software package, right? So we have all kinds of tricks we can play here. And if you notice, again, you've got these interwell points. That's what these guys are here. They're not on wells. They're picked in interwell space, and they can be adjusted if you feel like you need to tweak your fault. And because I have sourced from well base and it's recalculating the fault, and you've got fault offset, so it's going to be remodeling, if you will. Because we sourced from both and this is the trick, guys, because we sourced from both the data points on the IsoMap layer and well base, we can in fact come in here. Let me make sure that my fault 1 is the active surface. There we go. We can in fact pick additional interwell points to configure this fault beyond control. All right, so there it goes. It's putting that new interwell point in, and it picks up the subsea elevation from the point at which you click. Although you can come in here if you want to be tricky, you can come in here and go to your surface point editor, right? And you can actually put in an exact, so if you want this guy to be, instead of 3991, so negative 3991, I can make this thing negative 4000 if that's what I'm trying to do, and I can actually put in a new VS if I wanted here. I'll save that. So you can either pick up the elevation where you click, or if you miss slightly, you can come in here and edit it if you want this to be a negative 4000. So now I can take this guy and continue to tweak my fault plane away from that cluster of data points. Okay, there we go. And so now if I go back to my cross section, go back to full extents, and go over to my faults area, there's fault 1. I've got a number of faults that aren't showing up in here, of course, but just the beehive. If I want, I can turn them all off like this, boink. Turn the beehive back on, and then turn on fault 1. And there's a rather funky configuration for fault 1, but that is in fact our fault 1 that we picked, or that we sourced from a couple of different sources, but primarily from that IsoMap layer that theoretically I brought in from another piece of software. Okay, so sourced from seismic, sourced from a set of data points that I managed to get onto an IsoMap layer. And of course, just to kind of reiterate one more time, if I want to go in here and create another fault, let's say I interpret another fault to be in here in the space where I don't have any wells, recall that I can go into the well-to-well cross-section, click, double-click here, bring up a simple cross-section. Hopefully I didn't go too far away. I've got some surfaces in here. Let me turn all my surfaces on to get it really confusing. There we go. Come in here, zoom in. And if I wanted to create a new fault, just again to kind of reiterate how that all works, I'll click on the asterisk, create a new fault. I'll call this F4, color him green. There's so F4 will be created over here in the hierarchy. He's ready to go. Fault picking tool. And now I can come through here. Again, I'm in straight line mode, so let me hit F8 to go to true space mode. Again, that would be under draw modes, true space and straight line. So straight line is your classic, kind of what you're used to, correlation from well to well. Where you don't see any of the interwell geology and dipsy doodling going on. And of course, interwell points don't really exist in straight line mode, as an FYI but it's a gotcha, so be aware of that. Anyway, so I'm in true space mode with my F8 toggle. And now I can go ahead and pick my F4 fault in this area with interwell points, configuring it however I want. And then I can actually, if I know what my vertical separation probably is, I can come in here and add a vertical separation that'll be extrapolated along the length of the fault. And typically, as an FYI, typically the offsets will not occur until you fleshed out the fault to some degree, typically in map view. So it needs a modicum of data to actually behave itself. So if I come in here and turn my F4 fault on, you can see there ain't much to it. Just a few points along that cross section. However, again, right, just to reiterate, I can activate it, go to my interwell point picker, click within the fault. Make sure you click within the fault area where it's actually modeled. And I could tweak that and show you that in a second. And then you can go ahead and drag these points however you interpret that fault plane to be striking and dipping, and flesh it out. And if you wanted to because when you create a fault along a cross section, you don't get much in the way of modeling unless you come in. Let me go to my GeoSurface model properties again. You can always come in and, where's my F4? There it is. I can always create a larger quote-unquote extension factor, which will extend the contouring, if you will, of that particular surface or fault farther away from known data. Okay, it's kind of a geomodeling version of a boundary polygon, if you will, in IsoMap. I'll go ahead and change the extension factor. There we go. Now you can see I've got a lot more to play with in here. I can go back and I can create additional interwell points and let it model, do its little thing here. There we go. And again, if I want to start curving this thing to the southwest, I can start doing that. So I can configure this fault just the way I want to. And if I then decide, so then if I have picked too many, or maybe I've messed up on my interpretation. Let's say I've got 5 or 6 of these interwell points out here. Let me maximize that guy. Say I've got 5 or 6 of these interwell points out here. I could go in and do a big selection, and even though it's selected contours, don't worry, I hit the delete key. Do you want to delete the points and start over? Yeah, and it'll get rid of those interwell points. Okay, and again, if I push this fault plane map up to IsoMap, those points will come with it. Okay, well, I hope that this brief demonstration of some aspects of fault handling in GVERSE geomodeling has been maybe a little illuminating, some of the things you can do in here. As per usual, please send Christina any questions, ask any questions you have. She will forward them to me, and then I will get back to you with the answers to those questions. I'll look forward to it. And again, I just wanted to stress that while I've been showing you ways to create and edit faults here in GVERSE geomodeling, many of the same techniques can be applied to creating and editing surfaces. In particular, the ability to edit these surfaces or faults within map view with interwell points, which are real data in the database. Okay, and again can be pushed as data points over to IceMap and used over there, much in the same manner as that fault polygon was pushed. Okay, appreciate your attention. Again, please let us know if you have any questions. Thank you very much for your attention, and take care. Bye-bye.